So thank you, everyone. I know like this is a special kind of like time slot for our meetup. We're trying different things. We're innovating the whole pandemic situation, and it's super special as well. And I'm super excited because Michal has been like delivering so many things to the community, and actually tooling that I have been seeing more and more people using at work. We are using Babashka, almost on a daily basis for quite many things. So I couldn't be more excited to actually, hear a little bit more about his inspiration, where he's coming from, what the future actually holds for us, what he needs from the community as well. So I appreciate you folk, doing this on a Saturday, joining the session. Do bring your questions. Michal will take questions at the end. So if you have questions along the way, write them down and we're gonna get to them at some point. Like remember, like Michal is a great guy, very personable. And he also, Michal, correct me if I'm wrong, but like he used to play in a band, right? Like in a metal band. So you like metal music?
I did in a progressive metal band.
Progressive.
I was the vocalist and the keyboard player. But that's already like 13 years ago now.
But it still runs in your blood. So like I like mentioning that because like it connects more us more even more with you. Like not only using your tools and your systems on a daily basis, but also like with the person that you are. So without further ado, Michal, the stage is yours. Feel free to start sharing anytime.
So I'll start sharing my screen. I did prepare a presentation. Yeah. So thank you for having me. So I'll be doing a presentation about Babashka and GraalVM and taking Clojure to new places. My name is Michiel Borkent, but I'm also known as Borkdude on the internet. So if you Google Borkdude, you'll find more about me. I already gave a part of this presentation at Clojure D, but for this meetup, I updated it and I have some more room to elaborate on some things that I could not fit into the Clojure D presentation. So even if you have seen that one, I hope you'll get something new out of this. So let's get started. So what is GraalVM? GraalVM is a new technology, or relatively new because it already exists for a couple of years now. And what it lets you do is compile Java code or Java classes to native binaries. At least that's one part of the GraalVM stack. That tool is called native image. And I'll be exclusively talking about that part of GraalVM today. And the cool thing that GraalVM native image lets you do is it lets you create CLI tools from Clojure code that have instant startup. Let's, for example, the startup is less than 10 milliseconds, and that's not what we're used to on the JVM. So that's the exciting bit. So I already, before I created Babashka, I already created a couple of command line tools. And one of them is clj-kondo. It is a linter for Clojure. And it is distributed as a binary. It's also available as a JVM library and also available as an LSP server, but I think most people are using it as a binary. And so you can hook it up to Emacs and you get instant feedback about your Clojure code. Another tool is called Jet. Jet lets you convert JSON, Eden, and Transit between each other. It's a it's relatively simple tool. So maybe if you're looking for like a simple example of Clojure CLI tool built with GraalVM, maybe that's a nice example to look at. And it's quite similar to JQ in terms of what it does. So it also has a query language that lets you query your input. But one limitation of GraalVM is dynamic class loading is not supported. And what this means in practice is you cannot eval code at runtime. So everything you compile into a GraalVM native image, every Clojure expression already has to be compiled. And you cannot compile new Clojure expressions at runtime. So that's one limitation. But for a lot of tooling, it's already sufficient to do great things. But of course, I got interested if we could solve this eval problem in a different way, maybe. Let's see. So in Jet, I started adding a query language. And this query language lets you map with a function or a keyword over some inputs. And so when I implemented this query language, I thought, well, if we squint a little bit, maybe if we add more functions to it, it already becomes similar to a real Clojure. And so what if we extend this query language more and more? Can we make it into a scripting language that is, well, basically just Clojure itself? That is how I started building a Clojure interpreter. So it started with this idea in Jet, but eventually it became its own full Clojure interpreter. And that became Babashka. And the main idea in Babashka is you have some Clojure expressions, a script, but you want the fast startup time that you're used to from Bash. And you don't want to wait a second for the script to start. So that is what Babashka is. It's a native Clojure scripting tool. It's a single binary and you don't need a JVM to run it. You just download the binary and you go. And of course, I personally want to use Clojure for scripting and not instead of Bash, because Bash confuses me all the time. If I I always have to search if is a variable defined in Bash, how do you do that? Is it -z or is it something else? I don't know. I always have to Google it, but in Clojure I know how to do this from the top of my head. So I'm way faster in Clojure than in Bash. So I'd rather use Clojure. This tool is installable via an install script or brew or R on Linux for Arch Linux, or Scoop on Windows. Scoop is a similar thing as brew on macOS and Linux. So if you're using Windows, have a look at it. There is also a Clojure Scoop with a lot of other tools in it. So I recommend that. Let's have a look at the landscape of Clojure scripting tools that are already existing and how Babashka fits in there. So I benchmarked these, or rather a friend of mine benchmarked this on his machine just to have comparable startup times. So I used the tool multi-time to get a good average startup time. So for Clojure, if we start a script, on this machine that it was tested on, it took about 1 second to start up, and then your script started to run. Well, that's the JVM, or at least Clojure on the JVM, but it's by far the most powerful option. So you get interop with Java classes. It works on Windows. The execution model is it's compiled, and compiled code is often faster, or almost always faster than interpreted code. And you have real threads on the JVM. There is also Plank, which is a Clojure script scripting tool, or a Nrapple, and it also it's also compiled. It uses self-hosted Clojure script, which is also compiled, but the startup is still not that great. for scripting, or compared to Bash, because that was my reference point. So it's slightly better than Clojure, but not that significantly better. It does have interop with JavaScript stuff. It does not work on Windows, unfortunately, and it does not have threads. Then there is Joker. Joker is a Clojure interpreter, so it's not compiled. And it's built in Go. So it gives you access to the Go ecosystem. And it does not, the code, so the APIs do not look like things you're used to on the JVM. So you really have to learn these new APIs to script. So you basically, in my opinion, you have to learn a new ecosystem. But the startup is great. When I gave this presentation on Enclosure D, February, the startup time of Joker was still 50 milliseconds, and now they're down to 7. So they're on this machine. So they really made progress there. But what I wanted with Babashka, because I use GraalVM as the compilation technology, I envisioned that it should be similar to JVM Clojure. So you should have all the power that JVM Clojure gives you, but with the awesome startup time that, for example, Joker gives you. So the startup time is about the same, near instant, but you still get interop with the JVM, and it also works on Windows, and you do have real threads. So Joker doesn't have real threads. So that is where Babashka fits in this landscape. Let's see. So what are my goals with Babashka? Babashka should be a fast starting Clojure scripting alternative. It should be easily installable. It should be familiar for JVM Clojure users. It's not targeted at Python. Sorry. It's not targeted at Python people to win Python people over to Clojure, because if you're used to Python, maybe you're already a happy scripting person. But personally, I'm not invested in Python or Go or whatever. I just want to use Clojure, and that's what it's focused at. That's the target audience. Babashka is cross-platform, so if you write scripts, you write it once and you run it anywhere, like you do with Java. So it works on Linux, macOS, and Windows. And you still get access to the classes that the JVM ecosystem that you're used to, like system and file and Java time. Not the entire JDK is included in Babashka, but I made a selection of the most useful classes. And so sometimes someone asks on Slack, hey, this class is not in Babashka, can we maybe add it? And then if it's useful for like the broader audience for scripting, then I have no objection to add it. So why not add the entire, like all the classes? Because it also grows the binary. It does not slow down startup time, but it does grow the binary size. So that's why I'd rather not put stuff in there unless it's really necessary or useful for something. So Babashka gives you access to multi-threading, PMAP, Future. We also have core async even. And it has libraries included that I consider useful for scripting, like tool CLI, Cheshire, and more libraries that I will show later. And there is also access to external libraries and something called Pods, which is a new feature, which I will explain also in this presentation. So what are not the goals of Babashka? Performance. because if you want to have the best performance possible, you should be using compiled Clojure and not interpreted Clojure. But you will pay like the startup time on a JVM. But if you have a long running process, that's not an issue because it's long running anyway. And yeah, that's the trade-off. If you have scripts that are one-off fast things that you want to execute, then you go for Babashka. And if you have long-running stuff that is performance intensive, then you choose the JVM. But I do try to make Babashka as compatible as possible with JVM Clojure, so porting the code between the two should be trivial. Let's see. Yeah. And what is also not the goal of Babashka is providing a DSL for like a fancy mix of Clojure and Bash. I'd rather be just compatible with JVM Clojure than inventing some custom DSL. There are tools that do this. So if you like that, you can take a look at, for example, Cloj is one of those. And Cloj also tries to replace existing shells with entire Clojure environment. That is not the goal of Babashka. Babashka tries to play nice with the shell that you already have. So the idea of Babashka is that, well, Bash is anywhere, everywhere anyway. So let's try to integrate with that. So here is an example. So Babashka started like this one line. Sorry, there is something on my screen that I have to move. Yeah, it's the Zoom thing that got in the way. Okay, so Babashka started as this one-liner program that you could stick in between Bash expressions. That is how I first saw it. And so here's an example where you pipe the input of ls into Babashka. So BB is Babashka for short. And -I means that it will capture the output of ls into a lazy sequence of text, like strings. And that is captured in the input variable that you see on the end. And then you have this Clojure expression that filters over this lazy sequence and checks if something is a directory. So the output is an Eden expression that contains only the directories that was output by ls. So here we have this expression, but you can also predefine functions that you can put in your Babashka preloads environment variable. So you put a function in there, is dir, and then you can later use this everywhere in your one-liners in Bash. Because the Babashka preloads environment variable is executed before everything else. So you can also append expressions to that. So that's more for personal scripting, I would say. But later on, of course, I wanted to execute scripts, and I think that is the most common way of using Babashka maybe right now. So this got added later. So here we have a script, and it has a shebang on the start. So we invoke Babashka to execute the script. And then we do some time zone related stuff. I won't go into depth in this script, but what it does, it shows the time in California or in the Pacific time zone right now. So because I have some colleagues in that time zone, sometimes I just want to see what is their time right now. So this is just also to show that the script or Babashka supports interrupt. So let me maybe I can just show it, because I have the PST script on my computer. So here it is, and I'll just, well, it has a shebang, so I don't have to type BB, so I can just, so you can see that it's instant. So it's now almost 11:30 in the Pacific time zone. Well, sometimes I find it useful to know. So scripts. But the nice thing is this script that I wrote, it also works on Windows. So if I would have written this in Bash, then I'd have to reinvent this in PowerShell or something that Windows understands. And I'm not sure. There are, of course, you have Cygwin and stuff like that, but I'm still not sure if anything is compatible with Bash. And it's a lot of work to figure out all this time zone stuff in Bash. So I'd rather write something like this. And it works on Windows and it works on macOS and Linux. So I don't have to worry about other people using my scripts on other operating systems, which I think is nice. And Windows, maybe it's, well, 10 years ago, it was like considered awful and everyone went to Mac, but maybe now it's the reverse, like it's becoming hot again with the WSL2 stuff. And so maybe Babashka for me is also a way of preparing to go back to Windows, I don't know. So in Babashka, there are several libraries included and namespaces. So from Clojure core, we have the core namespace, of course. We have Eden, we have Java Shell, Java IO, pprint, set, string, test, walk, zip. So almost all of Clojure, the function namespaces with the pure functions or the utility functions are included. We also have Clojure tool CLI, Core Async, although I'm still not sure if Core Async is really that much used for scripting, but I don't know. So if you're using this, please let me know, and I won't remove it in Babashka version 2. But well, in the beginning when I created Babashka, I did not know exactly where it would go, so I thought it would be useful. And we have Clojure data CSV for converting CSV files, Cheshire for dealing with JSON. We have Clojure XML for, well, you can make scripts to extract information from your POM XML, for example. We have Transit, clj YAML to deal with YAML. I use this to generate Circle CI configurations, for example, using Babashka scripts. And we have Babashka curl, which is a thin wrapper around the curl executable with a Clojure idiomatic interface, much like clj HTTP. So it also has Clojure test. And what is cool, well, I think I wrote a unit test for a Bash script maybe once in my life, but now it's very easy to write tests for your Clojure scripts as well, because Babashka has Clojure test. And yeah, it has instant startup as well. So maybe I can show that as well. Yeah, so here I have that expression. So it will require a Clojure test. It will define a test and it will compare the number 4 to 5, which obviously fails. So I press enter and you already see, well, this fails. And also the exit code. Oh, the exit code is not correct here. I should fix that probably. But you see that it's just instant. Okay, I should not have checked the return code. That just occurred to me like during this presentation. Okay. Okay, I'll fix.
You're welcome. We just provided you with a bug report.
Yeah. Thank you. I'll take a note of that and fix it in the coming week. So what is the compatibility with? Can you all understand me? Can you all hear me? Is the sound okay?
The sound is perfect.
Yeah. Okay.
Thank you very much for.
Okay. Thank you. Then I'll just continue. If anything is not okay, just interrupt me, please. Okay. So the compatibility with JVM. Let's see. So can we run any program in Babashka? Unfortunately not. There is in the interpreter, there is no support for dev type yet, dev interface and reify. Although recently support was added for dev record and dev protocol. But this support is basically just syntactic sugar over, for example, in dev record, it's just syntactic sugar over hash maps. So you don't get any performance benefit by using dev record in Babashka. It's just for compatibility. So you can use existing code that already uses dev record on the JVM, and it can run correctly in Babashka. And dev protocol also, it's basically syntactic sugar over multi-methods. But I've already tested quite some code that uses dev protocol and it works. But the implementation is different. And code that does not use these constructs often works. So there are quite some libraries from the wild that already work in Babashka. But sometimes there is one or two missing classes or just a tiny tweak that needs to happen in the interpreter to make things more compatible. And so this is what I've been doing in the last few months, but it's come a long way, if I can say so myself. And Babashka supports to load libraries using existing mechanisms that were used on the JVM, which is the class path. So if you set the class path for Babashka, it can load code from a jar file or from a Git dependency. So how do you do that? There are multiple ways in Babashka, but one way is to set the Babashka class path environment variable, and you can use any tool to do this. So you can use Leiningen, or you can use Clojure, or you can do it manually. Like if you only want to add the source directory to the class path, you just set it to source. But to load libraries from Clojures, you want to be using Clojure or Leiningen. So here I have an example which loads a library that I wrote, which is called Spartan Spec. It's basically a stripped down version of Clojure Spec to make it compatible with Babashka, because Babashka has some limitations that it cannot just run Clojure Spec as it is right now. So, but it has most of the features from Spec, except instrumentation and generative testing. So if we add this library to the class path, then we can load this script that we have here, and then we can run our code that uses this library. So let me also give an example of this. So here we set the class path. Can you see my screen, by the way? Can you read this? Is it large enough? Okay. So here we set the class path using Clojure, and so this is a Git dependency. So it's already done because Clojure uses caching for class paths. So this can be very fast. And now let's see. Now we execute some code that uses this library. So I require the library, and then I write sexplain this spec with this data. So you see that it's still quite fast. So that's how you can use a library using existing tooling. Okay. So this is a selection of compatible libraries. That there are many more, but I think these are the top interesting ones. So Spartan spec I already showed. We have clj HTTP Lite, which can be used as an interpreted library. We have Medley, which is like a missing Clojure utility functions library created by James Reeves. We have Regal, which is an Eden way of expressing regular expressions. Camel, snake, kebab, which can be used to convert, well, camel, snake, and kebab case to each other. We have Arrow, which is a library from Juxt, which you can use for configuration. And we have Nubank docopt. Docopt is a command line parsing format that is, I think, popular in the Python community, but it's ported to all kinds of ecosystems, and it also exists for Clojure, but it also works with Babashka. Okay, so let's move on to next topic. So we have the Clojure tool, which is basically a bash script on Linux and Mac OS, which invokes the Java virtual machine. That is what the Clojure CLI tool is. And on Windows, it is implemented in PowerShell. So we have two different implementations, and it's a non-trivial script. And I wanted to see for myself if I could port this script to Babashka, because that would be a good test case for Babashka to see if it really fulfills its purpose. And that's what I started doing in the Christmas break of 2019 to 2020. And that became deps clj. It was a lot of fun porting it. It was pretty trivial too. I just went line by line and I started rewriting it in Clojure. And so there is a repo called deps clj. I didn't want to call it deps because maybe the core team, that was too similar to tools deps, so I just appended .clj also to emphasize that it's written in Clojure and not in bash or something. So this deps clj, it can run with Babashka. You see, well, it's basically a drop-in replacement, and it has similar startup as the bash script. So let me also show that. I have it on my path here. So you can see I have the shebang. So you can just execute it. So it just works similar to Clojure, but it's now implemented in Clojure itself. There is also a binary implementation of this. So a natively compiled one. I call that one deps.exe, just to emphasize that it's an executable, a native executable, and it also does exactly the same. So this one doesn't use Babashka, but this one does. So this is just a script. And that, for me, it was a good test to see if like Babashka can be used for serious scripting and not like 5-line scripts, but this is like a couple of hundred of lines. I think 300 to 500 lines of code. So after a while, or during the implementation of Babashka, I realized that I created some parts that could be useful on their own. And well, there are multiple now, but two of the most useful one or recognizable ones are Edamame, which is a Clojure parser. So every time you execute a script, the code gets parsed. And this is done using the Edamame library, which was first part of Babashka, but it was split out. And also the interpreter, which gets this parsed code and executes this form by form. So first, let me explain a little bit about Edamame. So the issue with existing Clojure parsers that I came across was that it did not work with GraalVM, because in some way they all used like runtime evaluation of stuff. And also I wanted to have location metadata on my forms and symbols, because I wanted to generate good error messages. So if you have a 1,000-line script and the only error message you get is, I cannot resolve symbol X, and you have this symbol X like in 1,000 places in your script, that's not convenient. So you want to at least know on which line and the column the error was. So this is also built in this Clojure parser. So it starts with parsing Eden, and then you can, via configuration, you can allow extra things on top of Eden. For example, function literals are not supported in Eden, but you can allow them in Edamame by setting the function option to true, and then it can parse function literals to S expressions. So it's just an S expression that it returns. It doesn't get evaluated. That's the job of the interpreter. And so let's move on to the interpreter. So the interpreter actually uses Edamame also for parsing. So you can go from a string to a real evaluated thing. So on the bottom, we see the same example of this function literal, and there it gets evaluated, and you get back a function. And when you call that function, well, that works as expected. And when I created this interpreter, I also thought it would be nice if this not only worked on the JVM and GraalVM, but also JavaScript. So it's a CLJC project, and it can also be used in the browser to evaluate ClojureScript. So even if you have a ClojureScript advanced compiled application, you can still use the interpreter in front end to evaluate Clojure expressions at runtime. The interpreter also has sandboxing options, so you can restrict the number of things that users can do in various ways. And it's also available on NPM. So you can just say npm install bork.sci, and then you can evaluate some Clojure expressions. Okay, how is this used by other projects? So one example is Molly. Molly is a data schema library which is created by Metosyn. And the idea, or one of the main ideas about Molly, is that your schemas can be expressed in regular Eden, unlike with spec, which is quite macro heavy. So this is more like hiccup style Eden for your schemas. But they also added nice features on top of this. For example, you can quote your functions if you want to have extra validation or relations between multiple things in your schema. You can use a function. For example, here we have a function that checks if the X element of the map is greater than the Y element of the map. And if you quote this function and you send it from the backend to your front end, it's still all valid Eden, So it can be parsed by Clojure script Eden parser, and then you can evaluate this schema. And if you have like this predicate at the end, it will be evaluated using the small Clojure interpreter. Because yeah, you have to have some way to evaluate this, and so you need some kind of interpreter for this if you don't have a compiler in your front end. So that's how Psi is used by Mali. I've also started using Psi in my other command line tools. For example, in Jet, which I discussed at the beginning, it has the option to keywordize keys, and you can just put a Clojure expression there as a command line argument, and now Jet will keywordize your keys using this Clojure evaluated expression. And because this is a GraalVM, because this is a GraalVM compiled tool, it's not like this was not possible before I had this interpreter. Recently, clj-kondo, so the linter, one of the problems in a linter, or specifically in a Clojure linter, is that, or Clojure tooling even, is that if you have irregular user-defined macros, often the tooling doesn't know exactly what the intention is of the macro. So if you have like a macro that has bindings in places that are not like let or other core macros, then you need to have some way to inform the linter how to treat this macro. So clj-kondo is a static analyzer, so it does not evaluate your macros. So it has to know from the surface as expressions what to do with this without evaluating it. So there are a couple of solutions to this problem. I could add built-in support, but obviously I cannot add built-in support for every macro out there. There is configuration to lint existing macros as if they are syntactically identical to built-in macros that clj-kondo does understand. That is already a very convenient option, but sometimes there are still macros that are not syntactically identical. And there is the third option to suppress warnings, but this also comes at a trade-off of suppressing useful information. So you can, yeah, I have an example here. So here I have a fancy macro called withbound. It's just an interesting name. It's just an imaginary macro. And it has a binding factor and a body. So, but what is special about this macro is that the author of the macro intends that the user can write a symbol. So if you look at the code at the bottom, a symbol and then a binding name and then a value and then some options. For example, the Clojure JDBC macros also have this syntax. And clj-kondo, there is not like a core macro that is exactly that covers this syntax. So the only way you had before was to suppress like all the errors, all the unresolved symbols in this expression, and then be done with it. But now there is a way to provide clj-kondo with some code which will rewrite the call to this macro into something that clj-kondo can understand. And so this hook can be written by the user, and this hook is evaluated using the small Clojure interpreter. So this is an example of the hook code. I will not go into the details because that will take too long. But just to illustrate, so the expression gets rewritten to something like let, and then the options just are part of the let body, just to get the linting correctly. So the expansion does not have to, or the way the hook rewrites the code does not have to be according to how the macro evaluates the code, just as long as the linter sees all the expressions and can make sense of them. So if you provide this hook, you get useful information instead of suppressing all the errors. So here we see that the binding A is not used, and the linter can tell us that. So this is how psi is used in clj-kondo. Let's see. So I'll skip this slide just because of time, but this shows how you can use add existing libraries to psi, but you can also find this in the README of psi should you want to use the psi library. Some more projects that are using psi. So obviously Babashka and clj-kondo and Jet, but also Spire, which is a Ansible killer written in Clojure. There is Bootleg, which is a static HTML generation library. Chlorine, which is a Atom plugin for Clojure, and some other libraries. So one of them is Bootleg. Bootleg is a static HTML generator. So if you have a file with some hiccup in it, you can pass it to Bootleg and it will generate the HTML. So it's a very nice tool to make your personal web page. So some new stuff that was added to Babashka since Clojure D. So Babashka now has a Nrapple server. So you can connect to this Nrapple server from your editor, and you will get auto completions, and you have LDoc support. So at the bottom of this Emacs buffer, you see Clojure Core Plus and then the arg lists. So that got added, Nrapple. Also, the Nrapple implementation got split out into a separate library. So any project that uses psi on the JVM can also use this library to get an Nrapple server inside of it. What's also new is Babashka Pods. So what do pods do? What problem do they solve? So Babashka already has a bunch of libraries built in, but adding more and more stuff to Babashka eventually will become a problem, because GraalVM is quite memory hungry. And if you add more and more stuff to it, it has to analyze more and more stuff, and the RAM usage goes up and up. And eventually there will be a limit to this, because on CircleCI, I used to have only 4 gigabytes. Now I have 8 gigabytes, but that's still a limit. And on GitHub Actions, I have 6.5 gigabytes or 7 maybe. So eventually it will end. I cannot no longer add stuff to Babashka. And also, not every library is useful for everyone. So even if I start adding like the most obscure libraries, like maybe only 0.1% of the people will be interested in it, and the rest will download this giant binary with stuff in it that they don't need. So that's also one consideration. And the third thing that I wanted to consider was, how do we access functionality from other platforms that could be useful for scripting, like Rust and Go and Python? So that's where pods come in. So the initial solutions that I thought of solving these problems was via feature flags. So there are feature flags to add Postgres support, HyperSQL support. And if you enable these feature flags, Babashka will have built-in support for this. And this is still supported, but pods were invented later, and so they became the later solution to this. And also we experimented a little bit with native libraries, like calling into C libraries from Babashka, but it's pretty hard to do. It is doable, but I got all kinds of segmentation faults, and it's really time consuming, and it's also static because Babashka has to know about all the possible libraries beforehand that you can call. So users cannot like build their own native libraries without changing Babashka. So that was a limitation that I also wanted to solve. So what is Babashka Pods? They are standalone command line tools that can act as libraries to Babashka. So you will download like another binary on your computer, and then you will tell Babashka, that binary over here, that is a pod, load it for me, and then you suddenly get access to more namespaces in Babashka. These pods, they can be built in Clojure or and GraalVM, or any other language like Rust or Python or whatever. Babashka pods, they use a architecture similar to Nrapple. So Nrapple is a protocol for invoking Clojure expressions. I use a similar model, but it's more like an RPC kind of architecture. And it uses a couple of data formats for this RPC, sending data back and forth. So these are some examples of pods that have come into existence. So we have a pod around Postgres and HyperSQL. So you can write scripts to insert things to a Postgres database or read things from a Postgres database. We have a pod around Edamame, which is a browser driver automation library. Well, the bootleg command line tool that I already mentioned also implemented pod support. So you can now use this same executable as a library within Babashka. We have a file watcher, which is implemented in Rust. We have a Clojure parser, which can preserve white space, which uses the Parsera library. And we have a Docker pod, which is implemented in Python. And we have more pods, but this is just a selection. So how does it look from a code standpoint? So if, for example, if we want to invoke the file watcher, then we say, well, I need the Babashka pods namespace, and then we load the pod. And the string that you give to load pod is just exactly the file name of the pod. So it can also be an absolute path if you don't have the executable on your path. It can be an absolute path or a relative path. And then we require a namespace from the pod. So, and that just works seamless, as if it's just a normal Clojure library, but this functionality is provided by this other binary. So you require the file watcher, and then we can just use it. Here I'm watching the temp directory, and we provided some callback to print the event that came in. So here, and at the bottom, you see the output. So I do have another example of interacting with Postgres, but hopefully you get the idea. So future plans. So sometimes I'm writing or adding parts to a book which contains examples for scripting in Babashka. And tips and tricks for scripting, it is located at book.babashka.org, but it doesn't have much content yet. So that will be a long-term thing. And I don't have like deadlines or whatever. I just work on that when I feel like it, basically. There are some ideas about making like more integrated support with dependency tooling, but that's not quite thought out of yet. So it's more like a hammock time type of thing. We want to have some more real integration with Clojure spec, but because Clojure spec is still alpha, I'm basically waiting for a spec to come out of alpha before diving too deep into this. And there is some work going on of adding Datomic client support to Babashka, so you can talk directly to your Datomic database and make some scripts for that. It will be supported via a feature flag, so it won't be in the default distribution. So if you want to have this, you will have to compile your own version of Babashka. But maybe it can also be implemented as a pod, and then you can just download that pod executable and use it like that. So for Psi, I want to add Clojure Datafy support in the future. That is a protocol that's not supported yet out of the box. I want to add support for smaller JavaScript bundles, because if you now use Psi as it is, you get just one choice. You get all of Clojure Core, and you get all of Clojure Eden and all of Clojure String. And maybe your interpreter doesn't need all of that, and there is no way to opt out of that. So so your JavaScript bundle is, I think it's like 200 kilobytes zipped, maybe, and unzipped it's even like 700 kilobytes, but it's still smaller than self-hosted Clojure script, by the way, which is more like, I have one site that uses self-hosted Clojure script, and my bundle is 1 megabyte zipped, 8 megabytes unzipped or something. So, but I still want to improve like the bundle size and let users have more fine-grained selections over what they actually need from the interpreter. Also, something that is being discussed right now in an issue in Psi is adding more control over duration or of the evaluation inside to prevent the evaluation from hanging. Like if you have a loop with too many iterations, that you have some kind of control to stop it somehow. So these are some ideas for the future. It's all up for debate. So if you want to have any involvement in this, please join the Babashka Slack or the Psi Slack. There are 2 different channels for it. And also you can reach out on GitHub or on Twitter, or I'm quite easily reachable. So final note about GraalVM and Clojure. If you're looking to build your own command line program with Clojure and GraalVM, there was one issue that kept coming back, which was an issue with the locking macro, but that is now solved in Clojure 1.10.2 Alpha 1. So I would recommend starting your GraalVM project with this Clojure version. And there is a repository called clj-kondo docs maintained by L. Reed and me, Lee Reed, and there are a lot of tips and tricks and hello world examples of how to get started with Clojure and GraalVM. And there is also a repository by Bruno Bonacci which has overviews of which libraries are compatible with GraalVM, and also examples, real code examples that test this. So these are the resources that I recommend for Clojure and GraalVM. One shout out to all the companies that are using Babashka and Sai. Yeah, it was quite exciting to create something that also gets picked up by not only like hobby programmers or people using like personal scripting, but also companies that are starting to adopt this. So if your company is also using Babashka or Sai or both, you can add your name to the GitHub issue on Babashka 254, and yeah, it's just nice to know who is using it. Okay, there is one recently, a few days ago, Jacques on Twitter, he told me that his company LiveCheck is using Sai, and the whole business is learning Clojure now, and everyone's scripting their own solutions. So even non-developers are learning Clojure now using this interpreter. So I think that's great. That extends Clojure reach even more, and even to non-developers. So that's quite something. So my conclusion, I think Clojure is just the best language for scripting. That's obvious. Okay, thanks to my sponsors. So I have now 43 sponsors on GitHub and on Open Collective. I have a couple of sponsors. So there's one company at Goji, which is quite heavily sponsoring me. I'm very grateful to them. There is a website called Ko-Fi, on which you can just buy me a cup of coffee if you have like a one-time, like if you're feeling happy about your script and you want to buy me a cup of coffee, you can do that over there. And there's Patreon. So I want to thank all my sponsors who also encourage me to work on this. And I want to thank you for listening to this presentation, and I hope you enjoyed it. And so now we have some time for questions.
And before we go into questions, Michiel, thank you very much. Like not only for the presentation, but for all the, I was going to say infinite amount of hours, but reasonable amount of hours that you have put into all these tools. And for a second, I even forgot that you wrote Edamame that I also use daily. So my huge vote of appreciation here for the amount of time you put and love into these things. So folks, questions. We have a couple of minutes for questions still.
Yeah, I realize now that my presentation was slightly longer than I anticipated, but I hope that's okay.
But you took your time. That's fine. Don't worry. So if you have questions, unmute yourself and ask around. Ask out.
Hi, Michael. This is Kanan.
Hello.
Thank you for the presentation. And I'm one of the biggest fan for Babashka, and I even contributed some documentation and other fixes in SCA. One thing that I would like to understand on the rationale for SCA and the problem it solves. One thing that I see is it helps you for sandboxing, and one of the rationale for which you started is like to work around a problem in GraalVM in which you'll not be able to use Clojure's eval. So I'm interested to know, like, so in all other cases, we'll be able to use Clojure eval, right? Instead of using SCA.
So Clojure core eval, it only works in the JVM and not in, so you can try it yourself. Write a Clojure GraalVM CLI that uses Clojure core eval, and you will just see that it doesn't work because it uses dynamic class loading. So what Clojure does is every time you evaluate like a function, then on the background it creates a class basically, and it can be an in-memory class, but it can also be a class compiled to disk. But in GraalVM native image, you cannot create new classes at runtime. So that is why Clojure core eval doesn't work.
Okay. So also in Clojure script eval won't work, is it?
Yeah, because that's Clojure core eval also needs the compiler. So you basically have to bring in the entire compiler. Yeah. And you can do that. Yeah. That is called self-hosted Clojure script. Okay. So that does exist, but it's quite heavy to use on the front end.
Okay, fine.
So I'll take a question from Andrew on the chat. He's asking if there is somewhere in which you have publicly discussed rewriting the Clojure script in Babashka, either blog post or something similar.
I don't have a blog post about this, but the README of depsale.j, it's quite well, you can see that as a blog post basically of why I did that. I gave a couple of reasons there. Maybe I can post a link in the chat. Let me look it up quickly.
There you go. Actually, Andrew himself, posted it. So like.
Okay. Yeah. Okay.
So we have.
Yeah. That. Sorry.
I was going to ask another question, but like, unless you have something else to add.
No, go ahead.
There's another question here. Do you have an example of an implementation of a Babashka pod using JSON instead of Eden?
Yeah. So, am I still sharing my screen? I don't think so.
Oh, you have to.
Yeah. Now I do. Okay. Yeah. So the file watcher pod, it is implemented in Rust, and in Rust it's far easier to use JSON instead of Eden because there are more libraries for that in Rust. So this is basically my first Rust project, so it's probably not the best Rust you've ever seen, but it does use JSON for communicating between Babashka and this executable. So yeah, that's an example you can look at, I think. And also, sorry?
Thank you so much. That's great. I didn't know that. Thank you.
Yeah, and the other implementation is, or example is Lispy Cloud's Docker pod, which is used, written in Python, actually. It also uses, I think, oh, wait a minute. Oh, Docker. Or is it written in Clojure? Yeah, it looks like it. Okay, I didn't know that. I thought there was one. Ah, I remember. There is pod Lispy Cloud's SQLite. That one is wait a minute.
Or is that like a name thing? Like you saw the PI there, and you thought it was Python.
I've sent to the chat.
Sorry?
I sent in the chat the example.
Okay. So there is one other pod that uses Python, but I cannot find it right now. Maybe it's here somewhere. Yeah, so it's just a gist basically. So you can see how short it can be also a pod. And this just gives you access to the SQLite via Python. And so it uses also JSON. So, yeah.
Thank you so much. Excellent. Thank you.
Any other question for you? We have another question for Josh, from Josh here, like, do you have any plans for supporting private pods in Babashka?
Private pod. So what would be a private pod? So Babashka does not have to explicitly support, like if you want to write a pod, you don't have to ask Babashka for permission. Basically, anyone can write a pod as long as it implements a certain protocol. If
right,
you,
but
sorry,
so
yeah.
hi, Rushikesh here. Sorry.
Okay.
What if you don't want to publish it, but want to publish it to a private repo or a private tools set somewhere?
Yeah, that's totally fine. So pods are basically just like any other executable. They are not hosted on Clojures or whatever. So you have to manage yourself how you want to distribute it, or if you don't want to distribute it, it's also fine. So you just keep it for yourself. That's totally fine. So what I usually do is, if I have a pod, I make it available through Brew, like other executables I also made. So it's not a difference there. So you can just install it via Brew, but you can also just keep it for yourself or for your company. That's your choice.
So I think that the important distinction there is that pods are not, they're just like the CLIs with a little bit of extra flavor running anyway, right? It's not part of like a management system or
right. Yeah, that's correct. Yeah.
So I do have a question. You mentioned very briefly, and I was impressed about Clojure tasks actually running on Babashka. And did I understand correctly that you would see Clojure tasks being used for not only for testing Babashka itself, but other things like other uses, Clojure scripts, for instance? Did I understand correctly, or was it like a...
No, well, what I was trying to say is that it's quite easy to write tests now for scripts, because the Clojure test namespace is included. And with Bash, that is not so common that you like. Bash doesn't have a built-in test framework, for example. So for Bash scripts, I usually didn't write any tests, but for Babashka scripts, you might consider doing that as well.
Okay. For Babashka scripts specifically, for some reason I understood Clojure scripts. I was like, this could be.
I don't know how that would work. But...
No, that's fine. Yeah, that's why for me was impressive.
Yeah.
Any other questions, folks? So we are running on time here, but maybe one more question.
Well, I don't have a time limit, so I would be okay to have another like 10 minutes, but it's up to you. Up to you.
Yeah, I have a question.
Go ahead.
Yeah, so my question is kind of like open-ended. It's I guess like I'm thinking about like deps.clj and like how like that kind of opens up like the kind of possibility to use Babashka as like a kind of application launcher. And I'm wondering if you can like talk a little bit about like, you know, like the relationship between like, you know, a JVM program and a Babashka program, and like using like Babashka as like a launcher for like a longer running JVM process and like an entry point to it where something like the Babashka script like spins up like a JVM process that like runs in the background as a daemon and then like serves as like an entry point to an already running process. Does that make sense? Is that a little too open-ended?
Well, that makes a lot of sense, and there are already also some people who have tried doing this. So one person, Jeroen, he's called Jeroen van Dijk. He made scripts which invokes Babashka where possible because of the good startup time, and in areas where that's not possible, it hands off to the JVM. And other people also have written like a launcher, if you are using tool CLI on a JVM, what you can do is first write a Babashka script that does this command line parsing for you. And if it fails, you know within a couple of milliseconds. And if it succeeds, then the JVM can continue. So that can be like a quick way of getting feedback if your command line arguments are correct. So you can put it in front of existing JVM programs. Yeah, totally.
Cool, thanks. I mean, I don't know if you have like a link to share like to some of these projects that you're referring to, but I would really appreciate that as well.
Yeah, I'm not from the top of my head, but if you join the Babashka Slack and ask Jeroen, I'm sure he has some examples of that.
So, and one thing that I could add here, because it just happened this week at work, is that there's also kind of the opposite happened at one project at work, where we had an integrant component doing some Docker magic within the JVM for like starting up the system. And because every single computer that we have now, every single server now has Babashka, and by the default, someone wrote a Docker inspect that pipes into Babashka, does a little bit of magic from within the JVM, from within the integrant component. So I was actually quite impressed that actually showed up in the code. Just not being a right? Like because it was handy, right? Like it was there, it was easy, and it worked.
Yeah. So the JVM shelled out to Babashka, basically.
Yeah, the JVM shelled out to Docker that piped in an inline to Babashka and then actually piped back into the JVM.
Oh yeah.
Like something simple, right? Like, but it came just making, well, yeah, we made a decision to make Babashka available in every single server. And just by being there, like people start using it because everyone is Clojure anyway.
Yeah. I've also seen someone, maybe he's here, I'm not sure. I've also seen someone do this from R, where they had like, they needed to transform some R stuff. So they shelled out to, I think it was Jet, but you can also use Babashka to convert something to Eden and back or something, and then read it back into R. And because it starts so fast, you can easily do that by shelling out.
You can easily ignore that it's there. Well, in our situation, because Docker was so much slower anyway, that Babashka didn't even make a dent. Do we have any more questions, folks? One more, maybe?
I believe I have one.
Yeah. Okay, is it possible to ask one?
Yeah, go ahead. I guess it's Alberto, right? Go ahead.
Yeah. I would like to thank Michiel for the video and also for the good job. I'm using clj-kondo, for example. I'm a beginner in Clojure and it's saving my life. I'm used to static compilation, so yeah, very appreciated. The question is, I didn't know that Babashka has a REPL. So I assume that the usage is basically to debug your script instead of saving, running. So you do it interactively from Emacs, for example. So anything to take into consideration. So you basically connect to the port and that's it. Or I didn't use it before.
Can you repeat the last question?
Yeah. So the usage of the REPL in Babashka. So how you run it and you are basically running your script interactively like any other Clojure program. That's the usage. Yeah.
Yeah. So a lot of I actually don't use a REPL for Babashka myself that often because it starts so fast. I just run the script, and if it fails, I change it. So that's usually how I work. But there are quite some people who want to stay within their Emacs and work the way they do on the JVM. So that's basically. I got a lot of questions to add Nrapple to it. And for me, it was also a learning experience. So how does Nrapple actually work? Because I never implemented anything around Nrapple. So for me, it was very nice to work on that from that perspective. But yeah, I think there are, well, the nice thing about working with Nrapple is also that you see the doc strings and the LDoc support, and so maybe the feedback loop is a little bit better for in that regard than just executing the script all the time.
And you can evolve from Emacs as you would, and it will be yeah. So you can do the normal workflow in that sense.
Yeah.
Okay, excellent. Thank you so much.
Michiel, once again, thank you very much for your time with us today. Thank you for putting all these things together. Thank you for being so responsive as well online when issues arise on these projects. And thank you for pushing the needle on expanding the surface area for Clojure. Like, this is great stuff. So definitely appreciate it. Maybe next time we have the chance of actually hosting you face-to-face in one of our meetups over here.
Oh, thanks for having me. It was a pleasure.
And thank you for all of you who joined as well. And stay tuned for more invites. We are checking to see if the next one will be presential, face-to-face, or if you're going to have another virtual one again. But thank you again for spending some time today with us.